Yo, welcome back. My name is Dr. James Utley. I am your resident codebreaker data scraper, and I'm here to give like kind of a brief walkthrough or just kind of highlight this course that I released in the school community. And our school community is called the Institute for Prompt Research. And so it's there. It's an amazing course, so I'm just gonna kind of go through it and teach about the machine learning foundations, which basically means that if you can understand these concepts in machine learning, which machine learning is what we know as artificial intelligence now, or AI, if you can understand these concepts, then you probably know 90, 95, 99% more than most people do around how the sausage is made, if you will. So let's get into it. Okay, yeah. The title of the course is Machine Learning Foundations, and essentially it's to apply statistical and mathematical techniques to extraction knowledge from data. Like it's real simple. Is you're trying to get insights from data to make predictions, and that's all really how that's what machines do in machine learning, and that's all you have to know. So here's the course overview, and again, this course is all found in the school community, the Institute for Prompt Research. You can join for free, and it's in the classroom section. So please check it out. I'm probably going to provide more of these type of things. So the Institute for Prompt Research is for AI researchers, and so like myself, and we're going to conduct research that is related to AI. Okay, course overview. These are related to fundamentals of understanding machine learning and translates into data science. It's really getting insights from data. So we're going to learn, like some core concepts and frameworks, regression and linear models, which is like my favorite, right? It's a prediction models using linear regression is amazing. Classification models, being able to optimize how a machine can predict something, like if it's a self-driving car, it can predict, oh, this is a stop sign, or this is and how well it does in the prediction. And then this is where you get in kind of like the advanced learning modules, which is neural networks and support vector machines, or SVMs, and computational techniques for efficiency, because what you're doing is building these neural nets, and that's where you see that they're real computational heavy. So you can hear on the news that these data centers are taking over the world, and they're consuming so much energy and taking so much water, and they're everywhere from Texas to Detroit, or Texas to Michigan, and outside of Detroit, and all of that, which is actually kind of true. Now the argument there is if you believe that or not. Meaning, if you believe that huge data centers with computation is going to be the future of AI, which I'm digressing, so we're going to move on with the slide. We're going to define some machine learning basics. Yeah, I guess before we get too far down the road, I should show you, like, this all comes from this text, which is called Undergraduate Fundamentals of Machine Learning, which is really the foundational concepts. And especially now, this is the only foundational concepts that you really need to learn. And it's found, this is a textbook, a college level textbook, and it is from Harvard. So they have a course, like a computer science course called 181, and it is from Harvard. I didn't go to Harvard, Hopkins alum. What? But I like this textbook because one, it looks like the fundamentals of a textbook. Like it's like nice and the text is like super boring, which I kind of like. But it looks, this is one of my favorite gradient boosters. Oof, so underrated. But anyway, it has some of the math. We got this lovely scatter plot here. Just data nerd's dream. Anyway, back to the course. So the course will go over some different foundations. And so this is where you can kind of incorporate some interdisciplinary type foundation backgrounds, such as, statistics, right? So when I started, this is a long time ago when I was an undergraduate, I sucked at statistics. I got like a D and had to retake it to get a C and everything. And then one day it just clicked. And I was like, whoa, the central tendencies and understanding statistics as a probability, as an applied statistic model. And then after that, it like seriously was a point that changed my life. Is understanding the mathematical models, and is really just a simple explanation of the coin flip or the wisdom of crowds or the law of large numbers, like those type of things, changed my life. And I have been on that path of like living that as my like internal dogma with my research, with my science, with investigation, as it translates to biology, as it translates to nature, all of those things. It's all based on statistics now, applied statistics. Uh, and so by that, you have to understand what an algorithm is, right? So it's a mathematical probability that then predicts something, right? And then probability theory, which is the taking data and understanding uncertainty around data, and then taking that same data, whether it's structured, unstructured, and then providing a technique that results in a prediction. And I think we're going to get to that. But here's the machine learning framework cube. Each dimension represents a fundamental aspect of machine learning approaches. One, output domain. What type of results does the technique produce? Two, statistical nature. How does the technique use and represent the data? And three, training type. What learning paradigm does the technique employ? And these are key concepts that you're going to kind of go through when you get through this course, when you're going through this course. So the dimensions, the output domains, right? So we have our discrete data or categorical data, and we have our continuous data. And you have to this is kind of the fundamentals of data. Like you kind of have to know about these type of terms and how they classify data. But sometimes what I have found is I can look at the data and I just can't explain it in such a a clear way, but I just know that it's categorical or it has a category or it's continuous or it's a migration of both and how to parse this stuff. It's just kind of it's easier done than talked about. And I think that's a lot of the fields that I work in are like that, where it's easy just demonstration is better than explanation. And I love that term. Okay, statistical nature, probabilistic techniques to incorporate data using the statistical distributions or summaries. It's more efficient. There's stronger assumptions that you can understand. Your data distribution is important. And so they have some examples here in the course, which is Bayesian methods or probabilistic graphical models and non-probabilistic techniques. So it's use the data to directly perform act, often require retaining the original data. It makes fewer assumptions, and it's non-probabilistic as a technique. And so they have examples, which is KNN or keep neighbors near, and kind of a decision tree. Training type. So I mentioned this one: the supervised learning versus unsupervised learning, and understanding what the difference is. So supervised learning, of course, is the mainstay of what I like, which is the techniques for linear regression and predictions, right? So you have the training and test data for predicting the future, which is predicting a state, or how close can you train a model to predict a state. Okay, and so to move through here, you're going to do there's some cards here to do the flip over, right? So we got discrete output plus probabilistic plus supervised. Oh, geez. Let's see. We are going to click that over and we're going to see logistic regression, needs Bayes classifier. That's the two techniques. Logistic regression. So that's not linear regression, that's logistic regression. You're going to have to understand what the difference is. So I have not so much experience in logistic regression because I work in quantitative science. And so the logistic regression is not my jam, but you'll learn it. Okay. Probabilistic principal component analysis, and so on and so forth. So this video here is just a primer of what the course looks like. Okay, so how would you characterize KNN for the classification and machine learning cube? We're going to say KNN is going to be some unsupervised data. We're going to go with this one. Am I right? Am I wrong? I'm wrong. Okay, KNN for classification makes it supervised technique. Hmm. So we're going to do, it's going to have to be a continuous output, discontinuous output, non-probabilistic and supervised, as I was. So we're going to try it again with this guy, and we're going to get it wrong one more time. Okay. Let's see. Thank you, Lord. Thank you, Lord. I would have got a set. I would have got a fail on this one. So, anyways, the point is, I've been doing this for a while, and that's not. And this because. So let's learn something there. Consider KMN used for classification. It requires storing the entire training set. You can say you can, as I mentioned earlier, I'm a gradient booster. I like gradient boost, and you can tell that KNN ain't my jam. But again, like I said, these are complicated topics. Feel free. When you're wrong, you just learn something. You know what I mean? And that is the best defines machine learning. Perform tasks. Hmm. All right, we're gonna get a one freebie, right? Boom! Right on the first time. Right on the first time. Bomb, bomb, bomb. Anyway, we're all learning. So that's the essence of this course here. You're gonna get into. Ooh, look at that beautiful background. Linear regression fundamentals. Okay, so here's one part that I want to point out is you get these like weird type. So you're gonna have to do a little something with that, which means like okay, let's go over here to the ZAI. I said, can you clean this out so it looks like format of mathematical? Um, you can use whatever LLM you want, but what had happened is like uh, how the course translated this made it kind of weird. Oh, but now it's like it's incorporating from the prior chat, but we should be good to go. Uh, okay, yeah, it's definitely overkilling this one for sure. For sure, but you can have it explained. So it just took that machine learning, and then what it did is it incorporated with the prior chat was the biological data part. But anyway, let's go over here to wonderful Gemini and be like, uh, let's start a new chat. We say this format is in, or let's just do this. We're just gonna do it. We're just gonna do it raw here. See what it outputs. I'm pretty sure it'll fix it. So it's just going to break down the formula. So if you ever have it, see, then it shows you the beautiful formula here. And that's going to happen all the way through this course because it's like buggy. So you can just take it. You don't have to like do. You don't have to do some crazy prompt preparatory prompt, but you can just it'll just update it so you can see it that way. I would say not. I would say do not be too concerned about the math. It just is what it is. Oh yeah, least squares loss. So this one's important, right? Which is like the least squares loss function quantifies the total error of our model by summing the square residuals across all data points. The factor is included in the mathematical convenience when differentiating this quadratic function penalizes larger errors more heavily than smaller ones, making the model sensitive to outliers. So that's which is a beautiful graphic there. Um, but that's understanding loss function. And when it comes to prediction and ML and training and test, and even when you're supervised fine tuning, loss function is going to be an important piece for you. But anyway, that is so. If you go through the course, you're going to learn all this cool stuff. Oh, yeah, maximum likelihood estimation, right, can also be derived through maximum or linear regression can be derived through MLE by assuming it has some assumptions. But anyway, this stuff is super fascinating to me, and I want you to enjoy this course and understand just kind of like the basic functions, foundations of ML. And you're going to learn if you know this, then you know more than 99% of people, like really about AI and ML. And this right here is quite dense. If somebody wants like this PDF, which is basically the textbook for like diving deeper, so you have like the course, which is the primer, and then you can have this is to dive deeper. Then just join the school community, hit me up, I'll send it to you, no problem. And with that said, this is the primer. So enjoy your time learning about all the wonderful. Ooh, this one looks cool. Mastering linear regression. And this is when, yeah, classification methods, especially if you like tagging images. So another part to think about here before I close this up is that you like there is a great effort to understand there's a sea of data out there, publicly available data that is not actually really kind of prepped for the training of AI. And so if we want to continue for the AI to be very smart and use, fact and not just Reddit posted scraped, then being able to prep that data is important. So learning about these techniques, you'll one know how the data is going to be used, But on the other hand is because you know how the sausage is made, you can prepare the ingredients, which is the data. So that is a skill that you can learn by understanding ML. And there's a whole market for that. If you have niche data, whether it's like the diameter of buttons to, how many vaccines were given in, some city in Kentucky, like those things are very valuable. That data is very disorganized or unstructured, and if you can put it in a data set that then it can be ingested by an AI, then hey, you're onto something, and somebody will pay money for that. But anyway, with that, yeah, I'm still clicking here. Ooh, we have arrived at a good place to wrap up. But this is gradient descent. This is what I was talking about earlier, which is gradient boosters, and that's a classification way. So it's like it iterates. Um, it uses this stochastic gradient descent. Anyway, it's fascinating. This is and and the other part is like practically using ML techniques to train models and whatever else. It's not really that difficult. It's not that many lines of code. It's not that difficult. If you can get the concepts more abstract, then hey, you can do it. All right, but I think that is probably a good place where we can stop here. So enjoy the course. It's in the school community, the Institute for Prompt Research. If you can't get in there, send me a message on any of my socials on Instagram, dr.james.utley. I'm on the Twitter or X as Sample Bias, like any of those places you can get me. Join the community, learn something about ML and AI, and I'll continue to put this stuff out because one, I want more people to be involved, and two, if we're all speaking the same language, it's fun. ML becomes fun, and AI becomes even more fun. All right, to all my nerds out there, peace.